Hey there, Marcus McDaniel here again for week 8 reading, I believe. So this week was we talked a lot about energy, potential energy, electrical potential energy, energy graphs. Most of it was relating to energy. So we kind of focused on, like multi-particle systems and how potential energy and like work are related, the formulas for there. We also talked about universal law of gravitation, which is another one of Newton's laws. Um, Another thing that I remember was like bounded, unbounded motion across these objects. So that was mostly what we talked about for this week was all energy related. So now the past knowledge that I've had, or like stuff that was a little bit of a review, I would say was more towards like the universal law of gravitation. I've heard most of these Newton's laws before. Haven't done a whole lot of work with them, but I've seen work being done with them before. Now, do I remember fully how to do them? Probably not. So I would also say that's something I will be learning again. Um, but in terms of like being able to recognize something, that was probably one of the more obvious ones that I recognized. Uh, and then another term that was used in the videos that was reviewed was reciprocity. Um, so this was talking about when it had like the magnitude of um, gravity forces, how like they're like equal in opposite directions. Um, but now using that, but what I learned was that saying that when they do have equal and opposite directions, only one of them is affected, and that's also due by mass size. So the example is like a soccer ball and the Earth. Now the gravitational force that they'll have are reciprocals, but since the ball has a lot lighter mass, it hardly affects like the Earth's motion. Um, Another thing that we started going on was that when we had two objects, um, and they were finding like the force onto by one, and then like obviously the opposite, and then they had like the little tangents coming out for delta r, and you're able to solve for the work, um, and just like kind of going through some problems. We found that the work is equal to the force of gravity times delta r, so that's another key formula. Potential energy is given by the fact of U, capital U. Now, some of the stuff that's like a little difficult for me is the integral portion of it. So like when I start to see that problem form, I get a little bit confused on what's going on. Even though like the problem itself, like when they gave the example, like I can see like okay, they just moved this here, moved that here, but there's probably more of like a reason behind why they're doing that, that I'm not fully understanding yet. So I have to, kind of get used to that and do that, because I mean that's a portion in math for my major that sorry, that's a portion like of the math in my major that we're going to be using a lot of and stuff. So getting the hang of that and just being comfortable with that should be very beneficial for me. Now the energy graphs, I could see how they were trying to go about trying to understand these energy terms. And another key point was that potential energy graph is always negative. So it was almost like in a log form, that just stayed below um, the x-axis. And so when they did the k plus u graphs, if k was on the bottom, that was false. That could not be right. Now the k graph is like the inverse, so it's always positive on the top, and it starts and it goes down, curving as like an upside down log, basically like a mirror image. And then when you add those two together, there's a line on the top above both of them, so it's got to be higher than both. That's the sum of the two together. So if the line's anywhere else, that's a false statement. So we also saw again Coulomb's law. So we kind of went through that again. Now for the integral portion, for me to get better at that, just practice, YouTube practice, Khan Academy, things like that. And I think after a while, I'll get the hang of it. It'll just take some time, but that's okay. Time's one thing we have plenty of right now. So that was basically the summary for week 8, and I guess we'll just move on to week 9 next week.